Hello everyone, in this video I'm going to talk about one supervised data mining technique which is called K-nearest neighbors. Supervised data mining includes classification and prediction models. In a classification model, the target variable is categorical and the objective is to classify class membership of new cases. Examples include classifying a list of prospective customers as buyers and non-buyers, or classifying a financial asset as buy, hold, and sell. In a prediction model, the target variable is numerical and the objective is to predict its numerical value. Examples include predicting consumer spending, the selling price of a house, or the revenue of a company. We have already learned two supervised techniques, linear and logistic regression. Linear regression is a prediction model, logistic regression is a classification model. In data mining, there is one important term that I want you to know: scoring a record. Scoring a record is classifying or predicting the value of the target variable of a new observation given values of the predictor variables. In this video, as I said before, I'm going to explain a supervised data mining technique called the K-nearest neighbors method. Often it's abbreviated as KNN. The KNN method has been used in numerous applications, including consumer credit rating assessment, loan application evaluation, fraud detection, and medical diagnosis. It is one of the simplest and also most frequently used data mining techniques for classification when the response variable is categorical, and for prediction when the response variable is numerical. So in KNN technique, if you have categorical variables as predictor variables and they are not numerical, then first you need to transform categorical variables to numerical variables. Another important point in KNN technique is it's non-parametric. That means it doesn't assume any underlying distribution. It's very practical in that sense because since real-world data does not follow theoretical distributions usually. KNN also belongs to a category of data mining techniques called memory-based reasoning. The premise of memory-based reasoning is that we tend to guide our decisions using the memories of similar situations we experienced in the past. For example, a credit card company can use KNN to evaluate a new credit card application based on information from similar customers. The KNN algorithm considers the existing credit card holders that are most similar to the new credit card applicant as its nearest neighbors and uses the existing information to decide on whether or not to approve the new application. So to make this more clear, I have one example here. You see here the data from a mortgage company, and this company is trying to determine whether or not a new applicant is likely to default on his or her home loan. So the new applicant is 36 years old and has an annual income of $64,000. The mortgage company extracts information from 10 previous customers with similar income. Here the income value is in $1,000 and age characteristics, as well as whether or not the customer defaulted on the loan. KNN algorithm works by identifying a number of existing observations. Here in this case, past applicants that are most similar to the new observations, which in this case our new observation is this person, 36 years old, and has an annual income of $64,000. Therefore, the central components of KNN observations are, first, similarity measures, and second, the number of nearest neighbors, or K. In practice, the KNN algorithm often uses the Euclidean distance to measure the similarity between observations. Here, in this example, you see that income and the age data do not have the similar scale because income is in thousands, age is 35 to 40s. Therefore, we need to first standardize the data before calculating Euclidean distance between observations. To show this process, here you see a scatter plot, and it's a scatter plot of age against income for the 10 past customers, where customers who defaulted on the loan are labeled with a red marker and, and customers who didn't default are labeled with a blue marker. So here this green triangle is our new applicant. Identify the 3 nearest neighbors in the green circle. In other words, we choose the value k is equal to 3 in the KNN algorithm. So as a result, we estimate that the probability that the new applicant will default is 1 over 3. So how do we find this? We know that applicant 2 default on his or her loan, 1 and 3 didn't. So out of 3 neighbors, one of them defaulted. Therefore, it is 0.333 or 33.33% chance that new applicant will default. The mortgage company can then going to compare this 33.33 with a threshold value. Let's say the mortgage company's threshold value is 0.5 or 50%. So 33.33 is the probability that the new applicant is going to default. 50% is the threshold. Therefore, the mortgage company is going to classify the new loan applicant as being unlikely to default. And this applicant will receive an approval on the loan application. What if the cutoff value is 0.25? If the mortgage company's cutoff value is 25%, then this new applicant will be classified as being likely to default. So therefore, the cutoff value is very important in KNN algorithm. And also, we say that the number of nearest neighbors are important too. For example, if k is equal to 1 here, then the closest applicant is number 2. Therefore, the probability that the new applicant will default becomes 1 over 1, which is 100%. So this is why it's very important to choose the optimal k for KNN algorithm. Next, I'm going to talk about how we determine the performance and model complexity. Since the KNN method is a supervised data mining technique, data partitioning is used to determine its performance and to optimize model complexity. The nearest neighbor observations are identified in the training dataset. As we did in the previous videos, we are going to determine the nearest neighbors in the training dataset. And analysts use validation dataset to choose the optimal k by minimizing the error rate. In some software applications, such as Analytics Solver, the test dataset is used to assess the performance of the final predictive model and the optimal k value. In the following video, we will see the application of KNN model using Analytics Solver.